Okay, yeah, so hopefully you guys can all hear me okay. If you came to my session on Tuesday, then that was, yeah, that's great. Nice to see you here as well. Unfortunately, this session isn't going to be quite as exciting. There's no hardware involved or anything like that, but yeah, I kind of wanted to talk about this, this new feature in LabVIEW 2020, and yeah, just kind of give people an introduction to it, because I think it's kind of a little bit unsung, but I think it's actually quite important, given the kind of age that we live in, that we should be securing our applications and that kind of thing. Um, so yeah, there's a few slides, and then yeah, I'll move on and hopefully show you guys some demos of the the new functionality that's been added. So my name is Sam. I'm a LabVIEW champion. I kind of sort of used to run my own NI alliance partner, but I went back to the dark side and now work full time for Agilent. But I still do kind of community projects and things like this and that kind of stuff. So that's kind of what I'm doing here. A long time ago, it was about 6 years ago now, I produced like a LabVIEW WebSockets API. So this it's on VIP, like the NI Tools network through VIPM, and basically this adds kind of WebSockets protocol support. So for anyone that doesn't know what WebSockets is, it's a kind of basically a messaging protocol that you can use to communicate between like a web browser and an application. It's kind of the only way that you can do sort of low latency communications, between a web browser and a web server, for example. Otherwise, you're kind of limited to, HTTP requests, which are, quite slow and there's quite a lot of overhead. But, once you've kind of established a WebSocket connection, it's quite a lightweight protocol. And, so it's then, quite, low latency. You can do asynchronous communication. So, either side, the browser can send messages, as events, and you can also kind of, the server can push data, down to the web, down to the, the client, the web browser, in a low latency way. Obviously, it also works for like NXG. So LabVIEW NXG Web VIs have basically a native WebSockets protocol. So that basically allows you to use my library in your LabVIEW application, and then kind of communicate with a web VI. And so I kind of showed that off on Tuesday, my demo with the analog to digital converter, that was running a web VI and communicating with the Raspberry Pi over WebSockets. And obviously, like because it's like a browser-based thing, it means that you can create kind of like user interfaces that run on non-PCs. So if you wanted like a user interface to run on a tablet or a mobile phone, a Raspberry Pi, then you can do that without kind of needing to install like a LabVIEW runtime and that kind of stuff on the user interface. The package was published in 2014. It went up to the Tools Network 2016. It became version 2 last year, so I kind of did a rewrite of quite a lot of the functionality of the library, and moved to a sort of a class-based approach, just kind of like simplify the API a little bit. Earlier this year, I think it was kind of at the start of lockdown, maybe, I kind of decided to open source a few things. So the source code for that is all up on GitHub. It works from LabVIEW 2013 onwards, so there's quite a lot of support for older LabVIEW versions. And yeah, definitely whilst under lockdown, I had time to port the library over to LabVIEW NXG. So the GitHub link that you see there, is an NI package for support for LabVIEW NXG. I kind of completely forgot about this. Obviously, the betas for LabVIEW 2020 were a while ago, but as of LabVIEW 2020, it's kind of natively included as a link in the data communications palette to install the library. So yeah, that was kind of cool that NI have not made it official. It's obviously not their product, but there's a link to it now within LabVIEW 2020. So in the last 6 years, without a doubt, the most requested feature that I have had and has kept coming up is secure WebSocket support. This is basically doing a WebSockets communication, like in an encrypted in an encrypted manner, basically over TLSSSL. So when we go on a website and it's HTTPS, that's the bit that indicates that it's a secure communication between you and the server. You can do WebSockets over the same thing. Obviously, like in the last few years, there's been quite a big push from like Google Chrome and that kind of thing to kind of sort of gently drop support for insecure websites, and there are certain things that certain rules that have been put in place. So if you're hosting a web page on a through a secure like HTTPS, you then, if you want to then do WebSockets, the WebSockets to that server or to that page, the WebSockets also has to be secure. I think it's called maybe cause, but it's some security thing that says basically if you've got like an insecure website, or sorry, a secure website, you can't load insecure assets from that. So if you've got a secure HTML page, then the images must also be secure, etc., etc. This has been kind of like a hotly requested feature for the library, and it's something that I've been kind of trying to investigate and pursue for quite a long time. The reason why it hasn't happened yet, kind of to give you a sort of a dive into it, but it kind of isn't that easy to add. There was no kind of native primitive support for this in LabVIEW. The HTTP client VIs do it, but that was kind of never exposed to us in a way that we could kind of access it. So we couldn't really tap into those to do like a secure socket connection. It's kind of difficult to roll your own. Cryptography is hard. Obviously with things like Heartbleed and all these kind of vulnerabilities that come out, you kind of these things it's quite difficult and time consuming to to deal with these kind of things. Also, if I was to really, provide a version of like OpenSSL or a secure library, well then, who's going to be responsible for patching that? So I kind of didn't really feel like I wanted that kind of weight and liability on my shoulders, if someone was to use this and for it to be insecure. So I kind of wanted to, leverage somebody else's work or some open source work to do this. Also, my library was is supported like cross-platform, so works on Linux RT and other targets. Basically it was just a wrapper for the primitive TCP/IP functions. So I didn't really want to lose that by adding secure functionality. And I kind of invested quite a lot of time trying to get OpenSSL working, with my library. I know it has been done. Basically, like NI for the HTTP client VIs, NI ship their own version of OpenSSL, which they update and maintain with patches. And I got some basic support working for that, but trying to wrap those functions and that kind of thing without creating a wrapper library was proving to be quite challenging. And there was even though I got kind of a basic proof of concept working, I wasn't really too happy with. Hang on, let me just go to. I wasn't really kind of happy with how it turned out. So I kind of, was kind of in a bit of a, I was kind of got a bit stuck with it, to be honest. But then without much fanfare and without much celebration or applause, in the LabVIEW 2020 release notes is a little section in there, a small paragraph, basically saying that LabVIEW 2020 has added basically a new palette transport layer security functions. And this is basically the missing piece of the puzzle that basically allows us to do encrypted TCP/IP communications in LabVIEW. That's kind of the release notes for that. I think I just want to go a little bit further and just go, yes, finally. I think this is, not particularly, people often don't think about security, it's kind of like a hindsight. But I think, these days it's expected. If you're working on a product, that does, network communications, I think it's kind of, you're kind of expected to do it. And until now, we haven't really had, an easy way of doing that, because, just normal TCP/IP is unencrypted. Anyone can, sniff the network and will be able to see exactly what data you're sending. If you're doing a control application, communicating with an RT target, running some industrial process, that you don't want someone to be able to, work out what the protocol is for that, and then be able to, send spurious commands, potentially, mischief, misdemeanors, mischievous behavior, that kind of stuff. If we're all working in kind of quite important industries, doing a lot of important work and stuff, and we shouldn't just develop this great application and just find that there's it's not very secure. So yes, this is I think really good, a really good step forward. I'll come on to now. There's a few more slides that I'll kind of cover a bit later, but I wanted to kind of show you guys, how this stuff actually works in practice. So I will just switch over to. I'll move this guy over here. I've set up a few kind of like sort of basic examples to show kind of how this works. There are some obviously like some built-in examples. So if we go into, I've just pulled these into here. So this is the first example, which demonstrates a TLS client and server communicating with each other. So we can see that basically it's opening up a server connection and a client connection, and then just testing that we can communicate between the two. So if we run that, we can see that it's matched, and the data we've sent is what we've received. The other example that we have here is connecting to a TLS server. So this is as a client. So this one just, it's not quite clear what it does, but you can see it's kind of trying to connect to ni.com on port 443, and that works. So to kind of extend that a little bit, so I've put together a little bit of a HTTPS client example. So basically what this is showing is that we can connect to a website, on its secure port, and we can, read data from it. So this kind of allows us now to, to communicate with a secure third-party API, communicate with, RESTful services that are running on secure clients, and sometimes, the HTTP client VIs just don't kind of cut the mustard, or if we're working with like a microcontroller that has like a really simple protocol or something, then we can communicate with it in a fairly straightforward way. So if I run this, this is basically just reading the headers of my website, so we can see that this was successful, that it used TLS, and that it was able to read the header data from my website. So we can change that. We can connect to Google. We can connect to kind of any website with that. That's running on a secure port. To show you what the code for that looks like. So basically, it works in exactly. It's kind of like rather than being a replacement for the existing TCP/IP functions, it's actually kind of like just an extension to it. So you'll actually notice that here we're using the same, basically the same TCP/IP VIs that we would normally. So we have, here, if I turn on context help, so here we have open connection. Here we have TCP write, and then we have a TCP read, and then a TCP close. So these are all functions that, if we've been doing TCP communications, we're all fairly familiar with. There's lots of other things that are kind of built on this. But essentially, there's not a lot of, it's all kind of fairly familiar and what we're kind of used to as LabVIEW programmers. What you'll notice is there are a few kind of extra bits and pieces added. So the first part we have over here is how we basically configure our TLS connection. So the way that it kind of works is we have our TCP connection, and then what we kind of do is we upgrade that to have to add the encryption onto the connection. So the first part that we have to do is configure our TLS configuration. So there aren't that many options in here at the moment. I'm assured that there are more options will be added in kind of future releases. But basically at the moment, all we have is whether or not we want to load the operating system trusted CAs. So this is to do with like the certificates that we can use to verify that the server we're talking to is the server we expect. Derek says load OS CAs finally. Yes. So what this means is in our when we access a website, on Chrome, basically the way that those certificates are verified is through basically like a number of like root certificate authorities. So there's like a small number that can issue certificates to say, yes, we've issued that certificate to that website, and you normally have to pay for the privilege. And that basically says, yes, that, I'm accessing google.co.uk or I'm accessing, mediamongrels.com or ni.com, and that, that's all, good. So yeah, by having that option set means that we're basically using the list of certificates that are stored, in our computer already, basically. We then have to make that configuration immutable. So basically, once we've set up our TLS configuration, we're then basically saying that we're done configuring it. We can now use this configuration. So this is important. I mean, it will give you an error if you don't call this, but essentially what this does is it allows you to reuse that same configuration across multiple connections. So obviously if we're doing a server application and we want to have multiple clients connect to it, then we basically only need to configure the TLS configuration once, and then we can then reuse that same configuration across multiple connections. So you kind of have to have a little bit of handshaking at the beginning and end of your application to say, create my TLS configuration, and then kind of clean it up at the end. But once you've kind of created that and made it immutable, you're then kind of free to use that across across multiple connections. So the kind of the other side of that then is you can see basically once I've made it immutable, I then pass that reference across to the far side, and I then release that configuration. So yeah, that's basically the configuration part. What you then have is once you've kind of established your TCP connection, you then have to do the upgrade. So in the TLS palette, I probably should have showed this at the beginning. So under data communications, protocols, TCP, transport layer security, we now have these additional functions in here. So new configuration, make it immutable, close the configuration. We can check if a TCP connection is secure, so if it's using TLS. And then we have like these two functions, which is start TLS and accept TLS. If you've done any like kind of text-based socket communications, that's kind of explains what the names of these where the names of these come from. But basically, you're starting, if you're a client, then you start TLS, you kind of initiate the TLS, the upgrade to the secure socket. But if you're a server, then you accept it. So you kind of have to, but it's the same kind of terminology that's used for like Barclay sockets. Is where that kind of comes from. So that's that. So yeah, so as I'm kind of creating a client connection, I'm talking to a server, talking to mediamongrels.com is the web server that I'm talking to. So in this case, I am calling start TLS. So what this does is this upgrades our existing TCP connection, to use the TLS configuration. And assuming that all is well, basically what that function actually does is it goes off and performs a bunch of handshaking. It sends certificates and keys backwards and forwards. I'm not going to go into the details of that. because to be honest, I'm not an expert in them. There are other people that will know this way better than I do. But yeah, essentially, a bit of handshaking occurs, and once that's happened, we then have our secure. Any communications we do after that will then be through the secure channel. All we have here is there's an option in here to just configure which certificate to allow. Not entirely sure of the difference of those, so yeah, if someone knows exactly what that what difference that makes, that would be great. And we do have to specify the host name that we're talking to. The TLS functions, obviously, it's not just about like encrypting our communications, but it's also making sure that we're talking to the server that we think we're talking to. So this is kind of important for protecting against what's called a man-in-the-middle attack, which is basically where it makes sure that we kind of have end-to-end encryption and that there isn't a server sat in between that could be decrypting all of our packets and then re-encrypting them between the server. So to do that and to verify that the server is the server that we say it is, that's why we have this. We have to wire in the host that we're talking to as well. And then yeah, once we've called that and our connection has been upgraded, we can then read and write the TCP sockets as normal. Any questions on that so far? Feel free to ask away in in the chat, or or unmute yourselves and. Oh, okay, all right. So yeah, that's basically like a. Oh, okay. Yeah, for some reason, Rich, it won't let me make you a panelist. I can try unmuting you. Hi, Rich.
Hello? Can you hear me?
Yes,
Hey.
can indeed, yeah.
Hi, my name is Rich Tullerton. I'm actually the NI developer who wrote this feature for LabVIEW 2020, and I didn't prep Sam at all for this, and so you're doing a great job, Sam. Yeah.
I hope I'm doing it justice.
Yeah, it does speak. I mean, it speaks to the potential success of the feature, but it being brand new, that like you're able to get a good beat on this whole API. Like looking into TLS, like the API, the protocol in general, like the story is trying to encapsulate a huge amount of complexity into things that
yeah.
that security non-experts can actually use. So there were a couple of things, a couple of important notes I wanted to mention on start TLS. If you can go back to that block diagram.
Sure, yeah.
So you mentioned the so the any trusted CA enum. So any trusted CA versus none. So if like in the HTTP VIs or any kind of API where you allow insecure certificates, that's what none basically is. So what that input specifies is what kind of trust you need in order to accept the certificate that the server provides. So any trusted CA is the default, which is you have a trusted CA certificate list and you validate against that. None means it will accept anything. So if you have an issue with a self-signed certificate, that can be a very fast way of working around it. It just disables the whole the verification that the server is actually the server you want to talk to. And also server name indication or the server hostname validation. If you do not wire that, I believe that it will not validate the server hostname.
Okay, yep.
So it isn't necessarily necessary. However, because of SNI support in a lot of web servers, you may not be able to request certain resources from certain web servers unless you have that nailed down. That's all.
Okay,
Carry
great.
on.
Yep. Thanks. Yeah, I mean, like I said, I guess this is kind of a testament to to NI for this, because obviously I was looking at trying to wrap the OpenSSL functions myself, in LabVIEW, and it is quite a minefield. There is a lot of different ways of doing things. It's quite a complicated API. Like, this is why there've been kind of like spin-offs of it to kind of simplify it down, for end users and that kind of thing. But I think, yeah, a credit to Rich, that this is actually, is a pretty, you add a handful of functions and you're now doing like secure communications. So yeah, I think, it's really good that that's been, that it's been done in it, in that way. It's good. Cool. All right. So yeah, that was basically like an example of doing a HTTP, like a web request. I've also got an example here of doing basically like a LabVIEW to LabVIEW example. So this is where I am the server, and also in a separate VI, the client. So this is the kind of thing that you might use if you were talking from an RT target to a host application running on a PC, then this kind of gives you that kind of setup and stuff for that. So what you'll notice is I've already pre-filled out the certificates and the keys that I'm going to use. But what I'm going to do is just start off by just running this, and just show you that's just show you that everything's working. So here I've got the TLS function switched off. So this is just doing an insecure regular TCP communication. Now, if I open up, so Wireshark is a utility for network sniffing. And if I look at here, if I listen in on that particular TCP port that I'm using, you will see that we can see basically my raw data that I'm sending. So we can see, I think this was from yesterday, which is why it's yeah, a little bit out of date. But you can see basically in here that the raw strings that I'm kind of sending and receiving. And if I open up the this guy and look at show packet bytes, then there we get in plain text, yeah, the data that we're sending and receiving. So if we're sending WebSockets data, we're doing TCP communications, then somebody, if all you're doing is sending like ASCII strings, then it's going to be really easy for someone to see exactly what exactly what data is being sent and transmitted. I'll come on to the certificates in a bit. There was a question from AJ about how to generate certificates, and I'll kind of yeah, I'll talk about that in a minute. So now if I switch on the TLS functionality, so all this is doing is all I've done is basically just just put some case structures around the TLS functions in both my client and server VI. So we can see the server one is slightly more complicated, and I'll explain how that works in a minute. But yeah, what I'm doing is just commenting out between the two. And if I rerun this and rerun this, we can see we are now communicating with TLS. So that little TLS boolean is lit up to say yes, we're on a secure channel. And if I clear this, there we go. Yeah, and if I quickly stop that, we can see here basically straight away that the protocol being used is TLS 1.2. So that's like one of the protocols used for security, for securing communications. Yeah, the TLS SSL functions only support TLS 1.2. Basically, anything before that, I think, is deemed pretty insecure, so you probably shouldn't be using it. And yeah, there are a few kind of newer protocols, and yeah, I think support for those will come in time. But we can see basically if we look at our kind of application data packet, it's garbage. There's no way realistically that I'd be able to pick this apart and figure out what data is being sent and received. So if I show you how the server side works, so here we basically have to, so obviously if we're acting as a server, we have to have a certificate, and we also have to have a basically like a private key. So the way that works is the server has to have both the basically like a certificate or a signed certificate, and then you have a private key which the server uses to then validate incoming requests. So what we do on the client side is we basically share our server certificate with the client that basically says, yes, we're allowed to talk to that server, and we can validate that server with this certificate. I'll talk about this a bit more in detail, and maybe Rich will have some comments on that as well. But yeah, basically just for now, basically what I've done is generated like a self-signed certificate. So I'm basically acting as the the certificate issuer. And using that certificate to secure my communications. So you basically have to, as before, we create a new TLS configuration. We load our private key from our private key file and specify which type it is. So PEM or DER are the two supported types. We also I've just clicked on something. We also specify our certificate chain. So again, I've used a single self-signed certificate, which means I only need that one certificate to approve, to encrypt the connection and verify, validate that the server is who I say it is. But what we've also got is if we were doing like a web-based application, we would need to kind of get a certificate from a trusted certificate provider. So someone like Komodo is one. I can't remember who the others are. Let's Encrypt is one. Gives you is for free certificates for websites, and basically they have their like trusted root certificate, and then what they will do is then they will generate basically like a certificate for you based on that, and what kind of the certificate chain means is that we kind of have to provide the chain of certificate. So from our certificate, basically up to the root certificate to be able to validate that. So if you were to buy a certificate, what they would usually do is they would give you the certificate chain that you would use for that. So yeah, again, so this is just a a certificate file. So I'm only using one certificate, which is the one that I've generated. And then basically all we have to do is add our private key and add our certificate to the TLS configuration. And then once again, we just do make that connection immutable. And then we have our accept. So this is basically, just like we had the start TLS. This is kind of like the server version, which is basically where we're listening out for an incoming upgrade request. And yeah, and then validating, upgrading it, performing the handshake to upgrade it to a secure, a secure socket. And then once again, at the end, we just, once we've closed that connection, we can then, close the TLS configuration. Richard just said, important safety tip, DER format loads do not actually work in the 2020 release, will be fixed by Service Pack 1. The workaround is to convert to PEM or load the file with read from binary file into a byte array. So yeah, just a tip if you're using DER certificates. And that's basically how we do kind of server configure, server side, communications with that. I think that was what I was going to cover in terms of demos for now. So I'll switch back to the screen. Okay. Certificates. So yeah, basically if we're acting as a server, we need to have a certificate, so that we can use that to validate the clients. So basically, what we can either do is we can either specify the server certificate as part of our client connection. So if I show that quickly, yeah. In my secure client connection, we can add our client certificate. So if we're using our own self-signed certificate, to make that kind of trusted and acceptable, to use for this connection, excuse me, we basically have to load that certificate and then, basically like add it into our TLS configuration. Yeah, and then if we're acting as a server, then we need a certificate and a private key file. So the private key file is really important. We shouldn't be giving that to anyone. We certainly shouldn't be having it yet in applications. Sharing it with anyone, because if someone has that private key file, they can basically pretend to be your server, since all they need is the certificate file, which you might give to them to be able to say validate that you are who you say you are. But if they also have the private key, then and that gets out, then they'd be able to kind of imitate your server. So obviously, yeah, that's if you've ever done stuff with like using certificates for like GitHub authentication or that kind of stuff, then you'll know that you need to keep that private key secret. Same with anything to do with like Bitcoin or anything like that. So yeah, when we do stuff on the internet, then basically you end up with a certificate chain. So you have the certificate that they give you that validates your server is trusted, and then that kind of works up. There's like a chain of certificates up to one of the sort of the root level authorities, and there's only so many of those out there, so that's why you kind of have to pay for them. Within our sort of applications, I'd be interested to have some like discussion about this. But kind of like if you're doing testing and stuff, then you can use like a self-signed certificate, like I did in my example. I guess if you're kind of deploying an application on a local area network, then what you might do is your IT department might give you a certificate signed through them or through their own certificate authority that you can then use for your applications. But I'm kind of not sure about how, if you were going to deliver an application to a customer, how they would, how you would kind of provide them with certificates. I know it's kind of like a big no-no to kind of give, to give them, a certificate and have your like private key kind of embedded in the application. But yeah, I'd kind of be interested if anyone has any kind of thoughts on that. Maybe we can discuss at the end. Yeah. Okay, so yeah, just to show a little bit about the certificates then. So if I move this back across to here. So you'll notice, so the way that we can generate the certificates, basically like as part of, I'll come on to it a bit later, but one of the things that the reason for this presentation is I've got like a secure version of my WebSockets library, and kind of to help me with generating certificates and that kind of thing. I actually wrote a little wrapper for OpenSSL, which kind of creates the certificates, a set of certificates for you. So if I show you that. So yeah, this is a VI that I created as part of my like WebSockets library, or the secure add-on to my WebSockets library, that kind of allows you to generate a certificate. So generally, the way that you can do this is by calling into OpenSSL. So shipped with the OpenSSL libraries is NI's distributed version of OpenSSL. Oh, I didn't mean to do that. Here we go. So as part of NI's shared folder structure, you have the SSL libraries, and then we also have openssl.exe. So what this allows us to do is allows us to basically run commands to OpenSSL. So there's a whole bunch of different commands and stuff that you can call this with. There's like utilities for like testing a secure connection, for it's got demos for doing client and server side communications kind of built into it. But it's also really useful for generating certificates. So you can use OpenSSL to generate a self-signed certificate, as well as using it to convert certificates between different types. So that's quite useful if you've bought a certificate, or you've got a certificate that your IT department have given you. You can basically use OpenSSL to convert that certificate into a PEM certificate that you can then use with like the LabVIEW functions. And so that's basically all this does, is it's just a wrapper that does a system exec call into the OpenSSL function and basically creates a a basic certificate, self-signed certificate that you can then use in your applications. So the way this works, if we run the VI, we can then specify a folder to create our certificates into. We have to give a common name, so this would be like our kind of like server name or host name. So add that in there. Yeah, we can fill in the basic information about the certificate. Yeah, add in our country, kingdom. We can specify a certificate validity. So typically you wouldn't have a non-expiring certificate because it just means that you can use it forever. And also, if you're doing like websites, you might have sometimes seen if you've got like an old website hasn't been updated in a while, there's certificates can expire. I think even NI's certificates expired at one point, and that meant that you couldn't do like HTTP client communication and that kind of stuff. So they typically have an expiry. Here I set it to 10 years, but probably 2 years or something. We can then add in localhost. So this basically just means that we're going to use this certificate basically just on our local machine, but we can also add in DNS names. So if we were going to try and use the certificate on a web server, then we would add in, like MediaMongrels.com to say that, this server can be used, to serve web pages from MediaMongrels.com. But, if you're doing like local application testing, then kind of all we need to do is, tick that localhost button. We can also add a certificate to our private key. So, a password to our private key. So that kind of stops anyone from being able to, open the private key, or use the private key without, it kind of encrypts the private key file. So you kind of have to enter the password to, to be able to use that private key file. There's also a button here for generating a .pfx certificate from your certificate. This was when I was kind of experimenting with the .NET SSL support, which requires a .pfx certificate. So if you tick that, if you want to use like the .NET SSL functions, then you can tick that and generate a certificate for .NET as well. So I hit the button. There's not a huge amount of like error handling and stuff in this at the moment, but I just got kind of enough to get that to get it up and working. But if we go to our new certificates folder, we can now see that it has generated the 2 files that we need. So we have our server.crt and our server.key. So this is our private key file, and then this is our our server, basically like our certificate part. We can open this up, and you can see that it opens up in Windows. We can see that it's not trusted. So we can see that it's a root certificate. It's not trusted, and we can see it kind of tells us what we could do if we wanted to, which is we could make this a trusted certificate by kind of installing it in our local machine. And you can tick this button and you can install the certificate. And once you've kind of installed it as a once you've installed it as a root certificate, you then basically don't need to specify it on the, as part of your client VI, because you're basically adding our new certificate as a root certificate, and we can specify the client VIs to use the OS certificate store. So if I actually open up my certificate store, so if I go to manage user certificates, and if I open up trusted root certificates, I'm hoping, so here we can see, here's the certificate that I've now installed into my certificate store. So obviously, again, this is like, it's okay for local testing, but you shouldn't really be doing this for production. You need kind of like a signed certificate, and you kind of need to have that issued. And it's kind of the kind of thing that your IT department might be able to issue you with, like a trusted a certificate that you can use for authenticating communications between your applications.
Could I chime in
Of
for a
course,
second, Tim? So yes, certificates are serious business. It is very easy to blow your own foot off with them. And there are numerous rough edges with the way all of it is architected and designed. The most important thing to realize with this is that a self-signed certificate is trusted as equally well as the top tier root CAs when you do this. There are things that could be done in the future to make it a little bit less of a foot gun, but there was not nearly enough time to consider them for LabVIEW 2020. The upshot of this is that, like, so let's say that you make a self-signed CA or certificate, like for your own server, and you add it to the root CA list, but you leave it exposed on your machine or on a USB key. And let's suppose that somebody else gets a hold of the root CA key that was used for the signing. Even if it's a self-signed CA, there's nothing, like, by default there is nothing in the CA in the certificate definition that means it only self-signs. So they can take that key and they can sign any other certificate for any other host on the internet with that key, and your computer is going to accept it. So when if you're using self-signed CAs, I would say that at a minimum, they instead of adding them, like, unless you're protecting them fairly heavily, and treating them like a real CA that needs to be protected, wiring them directly into the TLS primitives is probably a pretty good idea.
Yep.
Um, but nevertheless, having OS integrating the OS certificate stores into these primitives should, in the long term, greatly reduce maintenance risks or costs associated with keeping them up to date. So that's all.
Yeah, I mean, so like, I mean, one of the things is though that, like, I'm not sure how. So if I was to create like a WebSockets application, obviously like like Chrome would need to be able to trust that certificate, and that was kind of the bit that I couldn't really get by without kind of making it a trusted, a trusted
Yeah.
certificate.
Yeah.
So that's kind of where I guess where it comes into, like, if you can get your IT department to issue you with that, with those certificates that you can use for that, then that's kind of, I think, is the kind of the way to go for that, right?
Yeah.
Yeah.
Or staying on the public internet using Let's Encrypt. Those are all extremely good ideas.
Yep. Okay. So yeah. Yeah. That's that. Um, question. Can this be used to secure communication channel? Communication channel to a compact Rio from Michael. All communication channels. Does this work only with the raw TCP/IP comms? So yeah, Richard said yes, that's right. But Linux RTC Rios do have OpenVPN. So yeah, you'd be able to, if you were trying to do, I guess network streams from a RT target to a LabVIEW application, then you could do it through OpenVPN. But I don't think, network streams won't be secure. As a result of this, it's just the low-level TCP/IP functions.
Yeah, if you get a requirement in that the communication with a LabVIEW system, like, it in general needs to be encrypted, then the TLS, it is an application level framework. It doesn't guarantee encrypting everything. VPN type services are a good option. On desktop systems, IPsec is a very viable option potentially. It's just impossible to deploy. Um, there's some necessary complexity involved with all of this.
Yep. Okay. So yeah, that's kind of, shows you kind of how you can generate like a self-signed certificate. But there's plenty of documentation on the internet about that kind of stuff. I believe the NI examples include an alternative method as well. Server side. So yeah, there's a note in here about using CFSSL. commands to generate a certificate. But yeah, I kind of went with using the kind of included bundled version of OpenSSL and just a wrapper for that. So you can see, there's the if you want to pull this apart, you can get kind of the the command string there. And that works by basically creating a configuration file, an OpenSSL configuration file, which then gets loaded into the OpenSSL to generate the certificate. Okay. Let's subtract to this guy. Okay. So notes, caveats. So this is kind of the latest information that I have. I'm sure Rich will chime in if any of this is kind of out of date. But yeah, so the new functions, they're only for the sort of low-level TCP/IP functions. I've been told that it's cross-platform, including file app, as long as you've got the SSL, library, sort of component installed in Macs. I haven't tried it on a Raspberry Pi yet, but I don't know if there's any update on whether or not that works or not. I didn't have a chance to try it before this. It only supports TLS 1.2 and a fixed set of ciphers. So like one of the things I found when testing my WebSockets library is the server for that uses like TLS 1.2, but it uses an out-of-date, fairly insecure cipher. So at the moment, the list of ciphers that you can use, is hard-coded. But there's I think there are plans to allow you to change that. But if you're trying to talk to like a legacy system or a less secure system, then you might have you might run into issues where you can't you can't use TLS just because it's only supporting a specific set of ciphers and that kind of thing. PEM certificates, so if you've got certificates in another format, you have to convert them. But I think it's it's fairly straightforward to to find out how to do that using the OpenSSL executable. Performance-wise, I wasn't sure about if this has changed at all, but the encryption and decryption is single-threaded. So basically, as you increase the number of connections, then it's all going through a single thread to do the encryption decryption. So you can kind of expect to lose some performance. So if you're kind of expecting to have an application where you're doing 1,000 connections, and you try and add TLS to that, then you might notice that there's some bottlenecks around the the encryption decryption part, and also because of how it's how it's been done, you may notice that if you're adding TLS and lots of TLS connections to an existing application that also does unencrypted like TCP, the same kind of applies. It's all going through the same single thread. So it's just something to be aware of if you're trying to do high performance TLS encrypted sockets. There's no support for client certificates. So typically what we've been talking about so far is the server has a certificate, and as a client, we are checking that the server is who we say it is. There's also like client certificates, which is basically where the server checks that the client is who they say they are, and that isn't supported in the functions yet. It's a good way of checking that. It's how the GitHub stuff works. You have a client certificate, and it kind of checks that you are who you say you are, as well as checking that the server is who it says it is. Another little note from the release notes is that there's there've been a bunch of kind of digest functions added in LabVIEW 2020 as well. So if you're doing like SHA, like checksums, that's all kind of been added in there as well. Any comments on that?
I had a couple comments.
Okay, great.
So the performance issues, they do sound kind of scary. They were known in development, and we're actively looking at ways of mitigating or fixing the issues going forward. Some of the anticipated performance issues regarding interactions with unencrypted connections, we have not been able to nail down quite yet, identify, but there may be issues that will happen. Nevertheless, the APIs are not going to change when so it's we think it's ready for prime time for light use. But for LabVIEW applications with large amounts of traffic transferred over TLS, you may run into issues. Um,
Yep.
you should expect to see those performance issues solved before seeing any kind of um, control over cipher suites or cipher lists.
Okay.
Basically, solving getting property nodes for that is it's only a small stretch to go from there to adding property nodes for TCP sockets, which has been a very long requested feature.
Yes.
Yeah,
Yeah.
yeah. And so, but the reason that hasn't been done yet is there actually is a lot of plumbing that needs to get unclogged in order for that to happen. So I know Sam and I have been there's been a little bit of back and forth about adding INI tokens to hack in cipher lists. And it's just like right now, cipher lists is just a string of saying which algorithms are supported. And initially I was like, well, we can just add an INI token for that. And Sam was like, no, don't do that. That's going to be impossible to manage. And I'm like, you're right. You're absolutely right. So my gut feeling is don't like I'm not actually aware yet of a really good situation. Like besides echo.websockets.org, almost everything is capable of using modern TLS 1.2 cipher suites that are competitive with what TLS 1.3 offers. Um, and so I'm reticent to even add an INI token that people are just going to forget about, and then it's going to cause security issues on down the line. But
Sure. Yeah.
nevertheless, I'm very curious as to what people are going to encounter. So if you find deployments where you really need something like that, let us know.
Yep. Yeah, I mean, I think so. Obviously, like it's really great that I think it's the way that it's been packaged up, makes it really easy to add the add the TLS to like an existing application, because all you have to do is kind of change your handshaking code, and you don't need to change any of your like underlying TCP read writes. But I think it's if you've got like a high throughput application where you're doing a lot of TCP communications, then I think it's quite important just to be aware that if you add the TLS onto it, that there is kind of like a potential performance impact that's going to have. Obviously encrypting and decrypting has its own cost anyway. But yeah, just we're quite used to, I think, it with LabVIEW being very multi-threaded, and sockets being I believe pretty much multi-threaded, that that yeah, we just I think it's important that people should know that exists. But yeah, I think yeah, cool. Does NI offer some resources on learning the basics of TLS SSL? I don't think so.
No.
Okay. um, this is why you come to this session, right? Is so that you can learn a little bit about it. Okay, I'll move on a little bit then, because we're kind of yeah, up to time. So I just wanted to go through. So obviously one of the things that I'm pleased to announce is that there is now a beta package at the GitHub repository there, which basically adds sort of secure WSSS, secure WebSocket support for both client and server connections. So yeah, it's a beta package. I haven't had like a lot of time to do extensive testing of it. Basically, I haven't done any testing of it since the official release of like LabVIEW 2020, because I only upgraded this week. And yeah, but basically what this does is an add-on to, you still need the existing WebSockets package. And what this does is basically it's an add-on that kind of adds support for, yeah, the secure connection side. So all it's doing is just, wrapping up those, those TLS functions. So I'll just quickly show a demo of that, and then, yeah, and then I'm pretty much done, and we can, I can stick around for some questions. So yeah, I'm gone. So yeah, just to show you a quick example of the WebSockets stuff. So yeah, so very similar to kind of what I had with the, let's get rid of some of these. I'm sure we're all familiar with having way too many LabVIEW windows open. Okay, I think that's the wrong one. Okay, yeah, so here I have a secure WebSocket server. And I have a WebSocket client. Unfortunately, the demo that I didn't quite have time to get working was actually talking to a web browser. But yeah, basically it's the same kind of deal. It's just that you have to deal with getting Chrome to kind of recognize the certificate, for doing, local WebSockets communication. So that's where, when I did my initial testing, I had to kind of install it as a root certificate to try it. But yeah, there are probably more secure ways of doing it than that. So yeah, I'd if you're trying to implement a secure web application, then make sure you do do your research and stuff. But yeah, basically we can see that when we run that, we're now doing it's on WSS. And yeah, we can send and receive data to and from our LabVIEW application, yeah, over WebSockets. Close this one. So we can see basically, as before, you have to create the TLS configuration yourself. I didn't really see any point in kind of wrapping that up, but the new TLS WebSocket function, which is added in my new palette, basically is a new secure WebSocket client. So that takes in the TLS configuration and the service certificate validation, and then does the basically this will automatically switch between a secure and an insecure WebSocket. Insecure WebSocket. So if you specify the WSS, then it will try and upgrade it to a secure socket, and if you just specify WS, then it'll just use an unsecured connection. So yeah, this should work with third-party, WebSocket servers. Again, haven't done extensive testing, and unfortunately, because of the issue with the hard-coded cipher list, I can't test it with the, the WebSockets Echo, server. But yeah, if anyone knows of any other interesting WebSocket services, yeah, I'd be interested to to try those out and incorporate those into my testing. And then, yeah, if we have a quick look at the client side, we can see, again, we've created the TLS configuration for the server side. We have the socket listener. So I just wrapped some of the socket functions up, just to kind of tidy up the API a little bit. And this was kind of as part of wanting to add alternative socket mechanisms. So obviously, originally I was planning on kind of wrapping OpenSSL myself, or using .NET for secure WebSockets. So kind of having a low-level a class-based socket driver kind of meant I could plug in different socket types. We then can so this is just the exact equivalent of listening for a TCP socket, and then all I'm doing is upgrading that to a TLS socket, and then once we're there, a new WebSocket server, a new WebSocket connection, WebSocket handshake, and then we read and write, as we do before. So yeah, it should make it fairly straightforward then to kind of add secure WebSocket support to your applications. If certainly the WebSocket client stuff, should work pretty much out of the box. And please try the beta package and let me know if you have success with it or if there are any issues. Switch over to this guy again. So yeah, there's a couple of examples included in there. There's obviously the helper VI that I showed you for generating self-signed certificates. I say that with the caveat of on your head be it. Obviously, it's just to help you do that, but make sure you do your own research about whether you should use a self-signed certificate or not. And yeah, the add-on is obviously only for LabVIEW 2020 onwards, so it's kind of why I had to treat it as a separate add-on package. rather than incorporating it into the original WebSockets package. But that is it. That's me done. So I'll switch over to this. Yeah, that's everything that I had. Just this kind of introduction to the secure TLS SSL functions that were added to yeah, basically shows yeah, the basics of kind of how those functions work, how you can configure them, kind of a little bit of getting started, and obviously to kind of announce the the update to the WebSockets package, so that you can access it. So yeah, if anyone has any questions, then feel free to unmute yourselves and ask away, or any comments. Then yeah, I'd be interested to hear yeah, what other people think. There has a question from Greg about showing my kind of work in progress for the WebSockets guys. So yeah, I can do that whilst. And if anyone has any other questions, yeah, just feel free to shout out. No, if I can press the right button, there we go. So yeah, the demo that I was going to show was just, so this is using this kind of the server example that kind of comes with the library. So yeah, from a server side, there's no difference. It doesn't really care if it's talking to a a browser or another LabVIEW application. Basically, as long as we've got the certificates right and it can upgrade, then that will work. So I think it might just be, I might know why this hasn't worked. I think it's because I changed the certificates. But yeah, if anyone has any questions in the meantime, does that kind of cover best place to learn basic WebSockets is where? Are you talking about LabVIEW specifically, or yeah, or just kind of how it works in general? LabVIEW, yes. So have a look at, I've given a few presentations about WebSockets over the few years. There's also quite a lot of sample code and stuff on my GitHub. I've done a few examples with the Raspberry Pi, like my little democracy bot robot. I know there's a few sort of other examples floating around on the sort of LabVIEW community pages and that kind of thing, as well as my basic WebSockets library has got a bunch of examples yeah, built into it. So, showing how to communicate between a LabVIEW application and a browser, and between two LabVIEW applications. But yeah, kind of anything that you can do with a socket, you can do kind of over WebSockets. So yeah, what I'll try and do is when the video for this goes up, I'll try and kind of find some links and stuff for some of the stuff that I've done, and see if I can yeah, pull something together. Okay. Okay. This one example. So yeah, the normal WebSockets library, yeah, does include sort of a client and a server connection example, and there's also like a simple like WebSockets echo test as well. So if I up, so I think what went wrong was that I used the wrong certificate. So use the right one. Okay, so in theory, if I run this and like that. Yeah, I mean, I guess so part of the difficulty with this is that we can't really specify, when a web browser, you can't really specify which certificate to use for that connection. So that's kind of why we have to kind of install it somewhere where the operating system can find it. I don't know if there is like another way around that, but yeah. So kind of um, yeah, I think that's kind of what you're limited to in terms of that. So. Okay, it looks like there was an issue with generating the certificate, so that's probably why it didn't work. So fortunately, here's one I made earlier. Ah, yeah, okay. Helps if you specify the right one in the right place. Looks a bit more promising. So yeah, you can see basically like it hasn't closed straight away. I think it gets basically stuck doing the handshake. So that's probably because I have the wrong certificate installed. So I go, yeah. So yeah, we can see it's basically saying that it's not a trusted certificate. Um, so I will install that. So yeah, obviously, like it's important when you get a warning like this. But yeah, it's basically saying don't do this. So yeah.
I'm not sure about anybody else, but it's actually too blurry for me to read precisely.
Oh, okay. Yeah. I mean, it's basically like a warning saying that you shouldn't install this certificate. Yeah. On a unless you absolutely are 100% sure that you know what you're doing, and that there's considerable kind of risks involved with that.
So Derek raises a good point on the chat that I was wanted to bring up as well. Um, so typically like my understanding with like a WebSocket server deployment is that it's behind a reverse proxy of some sort, where you have a web server that has a binding to hand off connections under certain URLs to to a something on localhost or some handler, and you typically like you can have a WebSocket server bound to another port on the machine, but for a multitude of reasons, it is often preferable to have it uh, underneath the same web server that the rest of the system is using. And furthermore, there is like once you're in that situation, it is greatly preferable from a configuration standpoint at a minimum and a manageability standpoint for there to only be one TLS configuration running around, you know.
Mhm. Yep.
And so that would suggest the web server manage everything regarding TLS,
Mhm.
and WebSockets be to deal with essentially unencrypted connections. Now, the last time I personally dove into all of this was getting a Jupyter server running on a VPS like a year or two ago, like personally, and that was fun because like it all just about kind of works, but like it was all sufficiently new to get working that it was like the edges were surprisingly rough. Is so the way that people are deploying like presumably the majority of people using WebSockets and LabVIEW are using clients to a certain degree. or except for the WebVI case where WebVIs want to talk to a current generation lab, like a CRIO or something.
Mhm.
Okay. And now TLS support for WebSockets. Um, uh, the way you see that working, is that usually bound to a different port than the web server at the moment?
So yeah, in the stuff that I've done where like, I've written like a web VI or a JavaScript based user interface, then I'll run my LabVIEW on a different port. And so that kind of port is then dedicated to the WebSockets side of things, because obviously without hosting um, the web server within LabVIEW, you can't really do the handoff, right? So you kind of if you want to have a web VI or talking to a LabVIEW application, you can't really have it served through a web server to just hand off the WebSockets part. But I guess that's what Derek's mentioned in the chat is that might be possible to kind of pass off the WebSockets part to yeah.
Yeah, I know. Like I know that uh, Apache has, I think, has sufficient functionality to do a WebSocket handoff, and I think like both Apache, like System Web Server, and the NI Web Server, like I'm pretty sure they both have basic reverse proxy support. But handing off a WebSocket does require a little bit more magic. Um, and like there are some interesting questions that are raised here regarding uh, the deployability of such a scheme and how that relates to application deployment, RTEXE deployment, installer deployment. The you know like there are ways of hand hacking the server configurations to get this working, but presumably we're in the 21st century. There should be a better way of doing things like that. But uh, it, it does seem like an interesting a little gap. Like nevertheless, uh, having TLS support in like it's like server side TLS, it does mean that when you write code like this from the client side to interact with some protocol, you can build unit tests and test harnesses entirely in LabVIEW to exercise that, and it's all inside of LabVIEW. And I see that being like one of the bigger uses for TLS server support. Even if your web server is actually doing all the TLS work for you when you expose a server, you can still have a test that meaningfully exercises the TLS support in LabVIEW potentially.
Yeah, I mean, so like, I mean, I have kind of like a fairly specific like use case that I've kind of, developed all this around, which yeah, was the server side of, having an RT target, hosting a web VI that you're then using WebSockets to communicate between the two. So yeah, I always find it quite interesting to hear like what other people want to use this kind of stuff for. But that's kind of like the use case that I want is to, have an RT target sat in a cupboard somewhere that I can, use a tablet to, interact with it basically. And that was kind of where this, the WebSocket stuff kind of started from. Um, but yeah, so yeah, that's kind of where I want to, the things that I want to do with it. But yeah, yeah, it looks like I can't get this working very easily. So yeah, I think I'll probably just yeah give up on that because of the demo and all that. Um, but yeah, is there yeah any other comments, questions? Yeah, otherwise yeah, we'll call it a day there. Thanks for coming along. Yeah, definitely more people than I was expecting for this session. I thought it might be a bit dry. Hopefully you haven't all been too bored and yeah, learned something. But yeah. And again, as before, I'll put the recording of this up on YouTube. And yeah, if there are any kind of follow-up questions or anything, then feel free to yeah ask in the Discord channel, or reach out to me via Twitter or yeah. Okay. Thanks very much. Thanks, Rich, for coming along and yeah, chiming in. It was good to have some extra insight from there. Hopefully, I haven't yeah, led anyone astray, and yeah, but Okay. Yeah. Thanks, everyone.